Okay, I guess we can start. Welcome to the last show of the day. I'm between you and your dinner, beer, and whatever you have planned, but I still hope that you will enjoy the next 50-ish minutes with containerizing Foreman deployments. And I called it take 42, but luckily it's not the 42nd time I'm trying to do it, so I'm keeping my sanity, or most of it. Only most of it, because I've been doing that for a long time, and technology always gets me at some point. But yeah, let's try to automate things as much as possible. And yes, of course I am recording. Or am I? I am. All good. Thank you. But thank you for reminding, right? Yes, so let's see what our journey should look like or could look like. But every time that you look at the journey, you also need to look at the history, because you need to know where you come from. So Foreman was created in 29 by OHAT, and Docker was created in 2013. So we are even older than that thing. And at some point, 60 years later, OHAT came up with the idea, oh, we could have a Docker file in our Git repository and make developer life easier, which was great, but it's 2025, and this Docker file still exists. It just doesn't give you any meaningful way to run Foreman in a production environment, because it's designed for development. Not that it's not a valuable thing, but it's not exactly what everybody wants to have, right? And yes, we had containers before Docker. Just ignore that detail for a moment. What you still do today is a very classical deployment. You take packages, RPM and Debian packages, no matter. You install them on a system, you run our installer, hopefully, and get out of it a system that works in a very defined way, and just like as we tested. But you still have a lot of control. You have your control about which features you enable, which plugins you go with. You have a control what operating system you deploy on, etc. So it's a lot for you to like. You have a control, which is good, but there's also a lot of testing for us, because we need to test multiple different deployment methods or deployment targets, so to say, right? We would like to reduce that, because it's a lot to maintain, but also still give you a sufficient amount of control, because we know that not every deployment is the same. We can go there. And this is like where the existing Docker file is pretty much falling on its face. From one, it's built from source, which can be fine, can be not fine, depends. But more importantly, it has no orchestration whatsoever. It's one Docker file, and I think there's also the Docker Compose one, but it has a very monolithic way of thinking about things. And if you want to modify stuff, like enable a feature or install a plugin, you end up having to modify either that Docker file or inherit from it and build your own stuff. And there is no control whatsoever provided by us to you to make that simple. Sorry about that. It's even worse, actually. This Docker file existed since 2019, as I said, but until 2023, there was no testing that this file actually would build. And even so, we would push, like, we have a webhook to Quai that every time we commit something, it goes and builds a new container for you, also for stable branches, so you could keep like a stable Foreman version. But we wouldn't ever verify that things are still working. And it was broken at some point for months of when something in CentOS broke, and we didn't notice. Oops. Not a situation you want to be in. Like, we released a new version, but there is no container because it couldn't be built. So this is what like it looks like today, and we want to improve that. But also, not only we want to improve that, you also kinda go and say, we might want something new. It's 2025, and everybody wants Kubernetes, or the Kubernetes people try to tell us that everybody wants Kubernetes. And if you ask other people, at least everybody wants Podman or something similar, because it's easy, right? And those two interact quite nicely with each other, or at least can be used nicely. So we went ahead and started thinking, how can we make our lives easier, but also meet the demand that we see with the community, but also with customers who say, containers, maybe, yes, now here, let's do this. So last year we started a big research project, and I'll have links to that later on. But the general idea was, let's just throw everything out. Let's start fresh, new, green, and do everything better than everybody, including ourselves, did for the last 15 years. But we realized maybe we did something right in the last 15 years. Our packaging is actually pretty good for RPM. Don't look at me. And maybe we can reuse it, especially as the packages give us today already the ability to better document what is in the container, right? Because people want to know what they're running. And having everything packaged gives us a very easy entry point to that. There are ways to do the same for gems and node packaging directly, but having distribution style packaging is pretty easy, pretty nice. So if anybody wants an SBOM, it's much easier to generate from that, right? And at the same time, we also thought, like, where do we want to run it? The logical step is we can make it work with Podman because that's readily available in many places. And given that it's an OCI container in the very end, it's not specific to Podman. If somebody wants to run Docker, please do. You probably need to change a line or two, but then in the definition, but then it should work. And it also should be able to run on Kubernetes if you really want to. We do not want to limit you. And Podman also, what? Oh, sorry. So yeah, we are focusing on Podman, but there's a way to do the next step afterwards. So why exactly Podman? Why not LXC? Why not Docker? First of all, we still need to have this classical all-in-one VM experience for users who just want to have one VM, that's their Foreman or Satellite or Ocarina, no matter what label you put on it, and they don't want to care about it. That's a box, it's a black box for them, it works. And we think that we can pull that off with Podman, and it would still allow people to sometimes SSH into that box and do system control status, because Podman integrates with systemd very nicely. But at the same time, it also can consume Kubernetes YAML definitions. So if you have those, we can run them on one Podman machine, everything on one, or we can go and tell Kubernetes, oh, please deploy me my Foreman. And in theory, we are not there yet, but in theory, we would have one set of assets produced, and you can go and deploy stuff. And just for like completeness, we need Podman for 5.0 because that's the one that has the good systemd integration, and it is already in CentOS. It will be in Debian 13, and it will be in Ubuntu 24.10, so soon. We're not going to change this tomorrow, so we should have plenty of time for the tech stack to settle on that one. All right, so let's see what we will have to like dissolve from a Foreman system. I hope everybody sometimes seen this nice picture from Dirk, which describes like the whole Foreman as we sell it, or how we show it to everybody, there are users, there's an API, there's CLI interface. But the reality is, today, for today's talk, we focus on this yellow part in the middle, the main thing. Because for the user that's coming from the outside, they don't care what the machine is running, right? They access HTTP via HTTPS, and whatever is serving that, that's fine. And also the authentication backend probably shouldn't care. The compute resource shouldn't care where exactly the API request for them is coming from. So let's zoom in into that yellow part, and you'll see that I'm not capable of doing such nice graphics as Dirk. So this is uglier. And there are a lot of errors here because like all the services are kind of interconnected. And yes, this is more than Foreman core because I need to earn money, and I earn money by satellite, and satellite is Catello, right? So we include more than just a pure Foreman service, but it's also what a lot of people run. Foreman core itself doesn't bring a task engine, so you cannot run asynchronous stuff. So even if you don't want Catello, you still quite quickly end up with having Dynflow workers and orchestrations running. You still need Redis for caching. You still need PostgreSQL. So there's a lot of things that are need to be replaced. I'm sorry. And today, each of those boxes is a systemd service. Pulp is actually 3 services, and Dynflow workers, we also have multiple of them. But for simplicity, let's assume that's how it looks like. How do we pick the first service to replace? Just pick the easiest target, and it's not Foreman, by far not. If you ever had to deploy Catello, you've seen Candlepin here in the middle, which is responsible for all things when it comes to subscriptions for your client machines. It's a Java thing which runs in Tomcat, so it's already pretty isolated, and Foreman, or rather Catello, talks through an API to it via HTTPS. So where this API runs on, technically, doesn't matter. So we picked Candlepin as the very first thing. Interestingly, it's also the easiest thing to deploy because you just need a CentOS container. We picked CentOS Stream 9 because that's like what everybody else is using today. Let's ignore the fact that you need to configure repositories here. We then just go dnf install Candlepin, and if you ever want to actually run it, we define a command in the container file, how to start Tomcat. That's all, because the package will drop all the definitions in the right places in user share Tomcat web application, something like that. I don't recall. But it starts, it puts up the container, and luckily for us, there are no moving parts whatsoever. Like Candlepin doesn't support plugins. There are no modifications that we need to take to do to the thing before it can run. So pretty easy, pretty nice. But this is a container definition that doesn't give me a service running on my machine, right? I need to get from here to the service. So let's assume I go and build that and tag that and push that to a registry or have it locally. And then I go and have my, again, in our testing, we're using CentOS Stream 9, but it can be any modern thing with Podman 5. And we define a Candlepin container for Podman. This thing goes in itsy container systemd, and there's a systemd generator that then will create at runtime a service that you can trigger, you can interact with. So the interesting parts from this file is it looks like a systemd unit definition, just like it says container and not unit. The important part is an image. We have the candlepin image with a fixed version tag here in the example. That's one of the points that we are not sure about yet, how we do versioning, but that's for the future. We are cheating. In the past, candlepin was running as a service in Tomcat on localhost, and Catello is talking to localhost API with HTTP. And if you would run it in a container, the localhost in the container and the localhost on the host is a different one, which we can solve. But for the quickest solution, we can just say network is equal host. And at in that moment, everything that you open up in the container shows up on localhost on your host system. So obviously, the moment you're going to Kubernetes and have a multi-host deployment, this will not work anymore. But for now, this is a nice shortcut and also allows things like a candlepin talk to our PostgreSQL database, no matter where it is defined, etc. And then, because I was slightly lying to you, we don't need modifications to candlepin itself, but we still need to provide it with certificates. And we still need to provide it with a small configuration how to access database. We provide it with secrets. Secrets is a very nice concept in Podman, where you can create an artifact, a file, or a string, and then you can provide it here, for example, with a mount. So it will show up in etc candlepin certs, candlepin CA in the container. And candlepin CA cert, that's a secret that was previously created by Magic, which I'll talk about later a bit. And the same we also can do for configuration files. Even though they are not strictly secrets, but this was the easiest way to get data into the container without caring about file permissions, SE, Linux, etc., because Podman just does it for us. Great. And yeah, everything, all those secrets, today we just have some rather simple Ansible roles to do this. But our existing installation is using Puppet with installer, and we might use Puppet for a while and then deploying the containers with Puppet. We might not. This is a very open question, and we're hoping for a bit of input what expectations also you do have to us. So yeah, we have defined that and a system control daemon reload, because you always need to reload the daemon. You end up having a service running, or a service defined. You still need to start it, but it feels like it's a service that was installed on the system. You don't really know that it's a container. The only hints that you get, it says it's generated from this file, right? And if you see a look at the process output in the C groups, you see that there's like libpod thing and a conmon, which does a lot of things in the background for us, and it just works. But the important part is we have our Java application, like our Tomcat, that's running and is accessible from the outside. Pretty nice. It also almost automatically gives us logging, because everything that is logged in the container to standard out ends up in the journal, and you can search the journal, you can forward the journal somewhere else. Pretty cool. And this also gives you like a more traditional behavior. So if you're used to administering a system with systemd, which by now I hope you do, you can do this with that, and you can restart things, just works. Want to enter? The slide pause, so no worries. So This was an easy first step. We could replace Candlepin with the container. It worked. So the small thing worked. Let's just go and do Foreman now. Like no steps in between. And Foreman brings a couple of very interesting problems with it, right? We obviously again start with CentOS 9 because that's a base, that's fine. But we need to install actually more things than Foreman. We need to install PostgreSQL and Service and Redis because it's our packages are a bit split up, but we also install the Dynflow integration. And this is because we will be reusing that container later on for our Dynflow services, because Dynflow is conceptually still booting a Rails application and does a bunch of crazy stuff on top, which I don't understand, but Adam is. Or are you? Maybe, good. So yeah, but the more problematic thing that Foreman brings with it is plugins. I really, really love them, and I really, really hate them at the same time, because they give us like endless flexibility what you can do with Foreman and how you can enhance Foreman, but they also are very complex to handle. And our current idea is that we will be providing a way to to enable those plugins at runtime via some environment variable that might be called Foreman plugins. We are not sure yet. But we need to build them into the container already, because otherwise the code wouldn't be there, and code can be enabled. So, and then if you are like trying to adjust this container, for example, trying to install a plugin that we didn't pre-build for you, you would end up modifying this argument here. If you have better suggestions how to handle this more dynamically, please do. But so far, this is something that's been working okay enough in our POC, and that's what we are planning to do. One thing that Candlepin did for us, but Foreman does not, is database migrations. Candlepin just, when it boots up, it uses Hibernate, which is like a Java SQL abstractions thing, and it does then on top of that Liquibase migrations for the database, and it does itself, everything itself. So when it boots up, it sees the database is not migrated yet, it will just migrate and everything is fine. Foreman doesn't, and if you boot the Foreman on a non-migrated database or an insufficiently migrated database, you just get 500 errors, and it's like, you have migrations outstanding. Thank you, just do them for me. We opted into just, on every boot of the application, just execute migrate and seed for you. And in most cases, there will be no ops, right? But in the odd case that something changes, your database will be migrated. It might bite us at some point, I'm not sure, but so far wasn't that bad. And again, after building this container into an environment, we can define the running container for Podman, and it looks roughly the same, right? Sorry. It has an image. It also uses network host because we are keeping things as simple as possible for now. And it also uses secrets, but this time not only mounted stuff, but also type environment, which is pretty useful because you don't always need a file. And Rails has this nice way that you can say the database URL in an environment variable. So instead of writing a YAML file to disk and have to read it again, which is pointless, it's generated anyway. We can inject it as an environment variable, and it will consume it from here. And I guess for future, if we go with the environment variable enablement for plugins, you would somehow end up having here Foreman plugins as an input to your container, and that would define what plugins are actually enabled in your system. So, and as mentioned earlier, Dynflow is also a Rails thing. So we can go and define Dynflow containers, and we can use the knowledge we have from systemd again, which is nice. Systemd has this concept of template units where you can say, I have my something at dot service, and that can be instantiated, that can be started, but you can start something at worker 1, something at worker 2, and something at worker 3, which then gives you 3 services that are running with the same definition. Luckily, we can also do the same with containers. We say we have a Dynflow container with an add in it, and it would, if we ever start them, it would call them Dynflow sidekick -i. I is a variable that is then replaced by the whole templating in systemd, and it would start as a container. So we can start one for the orchestrator, because that's like the important thing that's doing the whole orchestration, and then workers as we need them. And luckily, as I said earlier, it's the same image, so we don't have to build things a second time. We probably could, but there's no point. Again, we have the same network host things. We need to pass the same secrets, so I abbreviated here a bit. And the only real difference is we have an exec definition, which overrides the one from the normal Foreman container, because here we need to call sidekick, which then boots Dynflow with the configuration, and that then is the Rails app, etc. I never understand that thing, but it works. But yeah, it's different code, just different entry points into it. This was the, I wouldn't say easy part. It was the kind of complicated part, but we're getting even further with a twist. The image at the beginning also had pulp in it, and we didn't have to build pulp containers because the pulp project provides them. Thank you for that. There are 2 types of containers that they have. There's an all-in-one, which brings everything. So there is a PostgreSQL in the container, there's a Redis in it, there's an Nginx, and all the workers, all the API stuff, everything. That was brilliant for prototyping because it could just show it and it worked. And then at some point where everything else was wired up sufficiently fine, we could pull it out again and replace that single container with multiple, which again are provided by the pulp project. So we only had to provide a bit of config. It was pretty awesome. But yeah, no code snippets here because it would look identically again, and you don't want to see that. So looking at the picture we had at the beginning, we replaced Foreman, we replaced Dynflow, we replaced Pulp, we replaced Candlepin. And I painted Foreman proxy in green. And I realized the green is probably pretty bad on the projector, but yeah. The reason I'm painting it green here is because we do have in our POC environment a Foreman proxy running in a container for Catello, because Catello, to know which pulp to talk to, needs to talk to proxy first, because that's how it does service discovery essentially. We will probably not go as far as containerizing the proxy in the very first run, because it has too many moving parts on its own, and this picture would just explode. if you would try to make that. And also what we did not containerize yet is the HTTP here and the databases. Our first approach was like just assuming those are present and care for them later, but also because it's not like our main area of expertise is, and we like didn't want to do decisions yet. But this also means that we are pretty much not there yet to ship Foreman in containers to you all in production tomorrow. I'm sorry. Oh, don't cry. But we at least know how many other questions we need to answer now, because there are a lot of them. And this talk is primary to raise awareness that we do want to do this. And like maybe you have more questions, maybe you have answers for some of our questions, and let's hope for the best, right? One thing that I mentioned in the beginning is installation is a big multiple question mark thing, because we used Ansible, but do we really want to write a new installer based on Ansible? Maybe not. But also, do we want our current installer, which grew over, I don't know how many years. How old is our installer, Eva? Do you know that? Yeah, so 10 plus years of grown Ruby, Puppet, and etc. code just to run a few containers? Also, maybe not. So this is a great chance to simplify, but we need to do it very carefully because we have all those existing systems, right? And because we are not replacing all the parts just yet, like the proxy is still running uncontainerized, we might not end up just being able to drop the installer tomorrow. But I'd like to at some point. But as I mentioned already, we need to care about existing setups. We cannot come to you and say, oh, by the way, you have to throw away everything and do a new installation. Ideally, you would be able to upgrade your existing one and you wouldn't notice. It's probably not going to happen, but we want to get as close to that not noticing as possible. And this also, again, will influence the installer decision that I mentioned earlier, because it's like so tight, like our upgrades are tied to our installer. So I don't know. Then one thing that we will have to figure out is how to properly do logging. I said that containers can log to standard out, and this will end up in the journal, which is great, besides the fact that our application do not log to standard out by default. In Foreman, we do have a configuration option for that, so that can be fixed. Apparently, it's very hard for a Java application to log to standard out, or the way it's set up in Tomcat for us. I don't know. So we had some discussion. It was like, yeah, we should do that. We have no idea. And again, props to Pulp folks. They already just do things to stand that out, and that just works. One thing less to care about. And then we come to this lower part of my graphic where things were not colored. What do we do with PostgreSQL? I've been doing PostgreSQL since 2010. No, lying. 2006, yeah. 2006 was the first time I touched PostgreSQL. And it feels very unnatural to run PostgreSQL in container, but maybe we will. Luckily or unluckily, RHEL ships with lots of tooling for PostgreSQL upgrades and stuff like this. And I have so far not found a good documentation how to do the same things in containers. So on Debian, on RHEL, I know how to do the upgrades from PostgreSQL versions. In containers, I do not. And Postgres is a bit tricky in upgrades. So we will have to figure that out. We will not have to figure out Redis because we use Redis only for caching, and we really don't care how it's deployed. So as long as there's a Redis or a Redis-like database thing, it will work. What we do have to care about is HTTP ingress. Today we use Apache because, again, this is something that has existed since ever. It works, it's well integrated, perfect. The moment we move to containers, and especially in an environment that is maybe not one single box, so looking ahead, right? Maybe you do want to bring your own HTTP ingress that Kubernetes brings or something else, and we should be able to work with that. But it also is very tightly integrated, so we cannot just take a random Nginx or Apache container and use it, because today our setup relies on the fact that the system, Apache HTTP can inherit things from the system it's running on, like crypto policies or the Kerberos setup if you have a Kerberos environment. This wouldn't work anymore in a container, so we need to figure out that. Lots of question marks, and I'll guess we will have a lot of angry people if we say we're dropping Kerberos support. So we should avoid that. The next question that I'm asking constantly is, what about packaging? I was saying that we are building the containers today with RPM package or based on RPM package because it was easy and gives us a trivially inspectable thing. But we don't really need packages for the sake of running Foreman. It just makes things easier. So maybe we should ditch packaging. And especially it makes things easier if we say our Debian packages aren't good, so drop them, maybe. I'm not promising anything, but I would at least try to get there where we have less parts that we need to maintain, and packages is one of them that we can drop, hopefully, at some point. Yeah, then Foreman proxy is one of those things that needs further thinking. We have no real idea how we will approach that because it integrates with so many services, and it's also plugin based, and we all essentially would have to rebuild all that in containers and also allow a lot of traffic into that container, which might be more complicated. So we try to avoid it for now, and we're probably going to do like the first round of here containers without a proxy. But we will have to think about that in the future because we should, like, we will diverge in a way, and we should then get back to one unified deployment solution at some point. Next thing that I found very problematic, or maybe it was me being used to, is if I deploy things as a package, I can SSH to a machine, fire up Vim, and just edit files in user share, gems, gem, Catello or something, restart Foreman, and my change is there. Unless it's something with assets in JavaScript, but Ruby changes worked at least. So you can very quickly apply a patch. Or we have this packet service available for everybody. So if you pull up a PR, that PR already has a built RPM attached, so you can try it out. This wouldn't work anymore without rebuilding the container. So the development and also the debugging, the live debugging, gets a bit more complicated, and we have to think about that and try to get that in a nice place. So yeah, and here comes you. Pretty sure that you have tons of more questions and hopefully also some suggestions for us. So there is an RFC. I'll put up the links, I'll put up the slides on the conference page later, so you don't need to remember anything of that. Go there, try to digest what you're trying to do, and also tell us your horror stories that you want still to be implemented after we're doing these changes. And with that, I'm saying thank you. And do you have any questions? Yes, Ian.
How the migrations work for the pulp container?
The question was how the migration work in a pulp container. And yes, I do. So Pulp, if you follow their own documentation of the deploy containers, they provide a Docker Compose file, which has a dedicated migration service, which is just the normal API container that they provide, which just runs Pulp Core Manager, which is like the Django admin interface, migrate. And this is defined as a dependency for all the other services that you start. What we did is we run that the same way we do it for Foreman before the application boots, because we didn't want to do another service. But yeah, that works. And it also even works if you boot the other ones before that, mostly. So yeah. But if there's any change, any problems with that, when we do further testing, we could then switch to the exact way how Pulp does it today. But it's you need to call a shell script essentially somehow. Yes, please.
Do you want to replace the Foreman installer fully with the Docker-based setup when it's finished? Or do you want to maintain both heads that I must not use Docker if I do not want to use Foreman in container, but I want to use it in a normal
VM, okay.
deployment.
So the question is, will the container-based setup be essentially the only way to deploy Foreman? I can imagine that being the case at some point in the future, but we are trying to still get it at the point that you still have one VM and you can deploy it one VM with a Foreman installer. It might have like something different underneath than today, but you will still be able to say Foreman installer, and it would start containers for you instead of services. Because that would reduce our complexity. Yes. The question is whether we want to have a blog post. Not yet. Do you wish for one? Like you will get those slides. The RFC also mentions a few things, and one of the links that is here is the Foreman Quadlet repository, which is our POC setup, and it has a huge issues list, which are like the questions that we're trying to track. And they're getting more. Like when preparing those slides, I think Ewout opened at least one more. So this is like our tracking thing. I guess the moment we will have a more clear picture of the future, a blog post might be possible, or might be a good idea, but right now the RFC and those slides are what you're getting. Jan, anything else?
I think it is where you explain how you do the signal.
Magic. So question was how we will do secret handling. So how it works today is you have a Foreman installer that under the hood using Python, Ruby, and Puppet generates certificates, generates one-time passwords, etc., and sprays them all over your file system. We will not be able to remove the fact that we need certificates, and we will not be able to remove the fact that we need credentials for databases, etc. What we have in our POC is an Ansible role that creates the certificates for us. And tomorrow it might be some Go code, or we might switch back to Puppet. But those certificates will be created somewhere and then will be fed into Podman secrets using Ansible or whatever solution, right? So today it's Ansible, but tomorrow it might be something different. And so that will be the secret handling. So it's not that much different to today, I would say. It just needs to be one more injection into Podman instead of dropping it in etc Foreman or etc Kennelpin. Yeah, Podman secret create, etc. If you want, that presentation is over. I can. I can't type. Yeah, I'll increase it in a moment. I want to hide the bad parts. So what happens today is we use community crypto to create certs. And then it's containers Podman secret, because today it's Ansible. And if tomorrow it will be something else, it will be a different language, but the concept will remain that we will feed it into Podman. And under the hood, it's Podman secret, create secret, etc. More question? I think you had one more? Or I think I've seen your hand.
How I can overwrite files then if you change it into containers?
Today you can't. That's an open question. So this is one of the things that I mentioned earlier, right? There is no good way to modify the running container right now. And we will have to figure out how that's supposed to work. What I did in my testing when I played thing around is I essentially created a 2-line container Docker file that says from my original tag, and then having a command that would alter my file and start that container instead of the original one. But it's not great. I agree with that. That's fair. Jan?
For plugins, you have to implement all possible permutations of plugins.
Ideally not. Ideally, we would come up with one fat container that contains the plugins, but they are not executed. And then you, as the admin, inject a list of plugins that you want to have running.
custom plugins thing?
Dirk, please leave this room. And for the recording, he was asking for custom plugins. You can rebuild the container, of course. But this is also, I guess, a chance to for us to better say those plugins, we know they're working because we built them into our distribution, and everything else, good luck with that. You had a question?
Sorry. Expecting that you're wanting to build that container daily, then because this container has sent a stream in there, so
Yes, yes. That's only theoretically true. They don't push packages to the mirrors daily, but yes, yes.
I think you're then extending the integration tests by far, right?
Because we need to integration test CentOS, the base test node. Yes. We might end up switching to Rocky or Alma or UBI, which yes, but then it's more weekly that we need to rebuild.
You don't have a state of packages anymore in your repos, which in the RC phase gets tested. And when the distribution changes something very, I don't know, something happens, you rebuild the container, suddenly everything is broken, and a customer or whoever does a new pull, runs.
Yes. But doesn't the same happen if you DNF operate during system?
Right. But
like it moves the target a bit, yes.
Yeah, at least in my mind, you have to rebuild everything.
Yeah, we will have to
target. But we can have multiple tags, so
a lot of tags, yes.
Yeah, that's
yeah. Or maybe our registry will have some magically security option to tell us what's in the container, what actually changed, because we only need to yes. But yeah, like we only need to rebuild if something's changed that actually, like not the mirror push happened, but something in our container changed. So yeah, but good question. I'll add that to our problems afterwards. That's fair. Why is that going to sleep? Don't go to sleep. Hmm? Yeah. Yeah. More problems? Questions? Beers? Chocolate? That's Swedish candy.
So yes, candy.
That's dangerous candy. Okay, then thank you.